Now let's look at derivatives of logarithmic functions. There's the formula for the derivative of ln of x. Ln of x goes to 1 over x when differentiated. Note, remember, ln of x is log of x to base e. E is the magic link in calculus. It's the only way we can end up differentiating any powers or logs is by going through e. So let's look at some examples. Ln of 3x. Well, 3 is just going to stay there, so we end up with, in fact, the outside function is ln of u, inside function 3x. So 1 over derivative of the outside, 1 over u, times derivative of u, 3, which becomes 1 over x. Notice that we could have instead separated it by the log rule that says log of ab is log a plus log b, which makes life much easier, in fact, because ln of 3, when you differentiate, that's a constant, so it goes to naught, so we add only 1 over x. In this case, note, ln of x all squared is not 2 ln x. If you look at the next one, yes, that 2 can come down in number 3, and we'll have 2 ln x, but not number 2. That cannot be simplified. So we have to see it as a composite function, outside function, u squared, inside function, ln x. So u prime, the outside function prime, is 2u to the 1. So 2u to the 1, where u stays the same, multiplied by, and then derivative of the inside function, 1 over x. Outside function in number 3, ln of u. Inside function, u equals x squared. So when we differentiate the outside, we get 1 over u, or 1 over x squared, times differentiate the inside, 2x. Of course, there is an easier way. That becomes 2 over x. There is an easier way, quicker way. That is to separate take that 2 and bring it to the front. So d by dx of 2 ln x by that log rule that says you can do that. And that goes straight to 2 over x when you differentiate, instead of having to use the chain rule. Please note in future, always use log rules to simplify where possible before differentiating. It'll make life much easier. Product, 3x squared, v equals ln x. So it's u prime v plus uv prime. And so that becomes 6x ln x plus, and then that stays the same, derivative ln 1 over x. And that's the answer. This one, we could have done that as well. This is derivative of, no, we couldn't have done it. Sorry, I'm talking nonsense. That's the only way to do it. This one's a bit complex. We have to do that by quotient rule. Please notice you cannot take out the x here because that is ln of x. So we're going to use quotient rule. The green is the u and the pink or whatever is the v. So it's u prime v minus uv prime over v squared. So here's u prime, 1 over x plus 1, times v as it is, ln x plus 1, minus the top as it is, u as it is, times the bottom, ln x plus 1. Well, ln x goes to 1 over x, and 1 is a constant, so it disappears. And it's all over the denominator, v squared. Multiplying out the brackets, so 1 over x times ln x, there we are, 1 over x times 1, 1 times ln x, 1 times 1, minus outside means to change that inside to minus, and 1 over x multiplies each of those. When we simplify, some of the ln x over x goes and the 1's go, so we end up with just 1 over x plus ln x. I'm now going to cancel up. I'm going to multiply by x top and bottom to get rid of that fraction inside the fraction. So there are x times 1 over x, 1, x times ln x, x times that squared bracket is x outside the squared bracket. Here's some exercises for you to do. Pause this first and try it first yourself. Notice there I'm using a log law to simplify that. That's very simple then, because it goes straight to 1 over x, because derivative of constant is 0. This one we cannot use a log law. Note, ln x all cubed is not equal to 3 ln x. If it was ln of and then x cubed, just the x cubed, yes, you could. So this is composite. Outside function, u cubed. Inside function, ln x. So we're going to say 3 ln x squared, 3u squared, times a derivative of the inside, 1 over x. Simplifying slightly. Here is a product rule. So we have ln x is the u and v is the inside of that bracket. There's product rule, u prime v plus uv prime. So u prime, ln x differentiated, v as it is, plus ln as it is, u as it is, times v prime. Derivative of e to the x is still e to the x. Derivative of minus x is minus 1. That we can multiply out to there. Well, yes, multiply out, simplify brackets to there. But it goes no further. Let's have a look at the next one. This is a product. But notice that we can expand that using the log rules, log laws. Ln of ABC is ln A plus ln B plus ln C. Then we can go a step further with the ln of e to the minus x. The minus x can come to the front. And ln of e is 1. So we end up with just a minus x. Makes life much easier. Now we have 3 terms to differentiate. And this one here is a composite rule. The third term is a composite, it's chain rule. So, minus 1, notice the ln 2 is gone. So minus 1 is derivative of x, minus x, plus, and then the outside is ln, the inside is sine of x. So the outside prime is 1 over sine of x, 1 over u, times the inside, derivative of sine inside is cos. Which we can simplify a bit, and it looks neater still if we write it as cot x minus 1. This one here, we're going to simplify by log rules first. Log of a over b is log a minus log b. E to the x, ln e to the x comes to the front. And ln e is 1, so we have x minus ln of 1 plus e to the x. Please do not expand this and say this is ln 1 plus ln e to the x or minus ln e to the x. You cannot expand or simplify ln of a sum, a log of a sum. Only log of a product or log of a quotient. So that's going to go to 1, the x. This one here is once again a composite rule, chain rule. The outside function, ln, inside function, 1 plus e to the x. So there your 1 from the x minus the derivative of the outside function Outside prime, well, outside is ln, so 1 over, and then that stays the same, times, and derivative of the inside function, 1 goes, and derivative of e to the x is e to the x. Our final one is a product rule, and here we have a composite, and there we have a composite. Oops, oh yes, that can simplify. If we actually bring a common denominator, it actually ends up as being that. Notice I brought down the 2 to the front in the interest of the way of simplifying logs first. It does make it easy because this is no longer a composite function. It's no longer a chain rule now. Now we have a product. U equals sine of x, v equals 2 ln x plus 1. And there it is there. So now, derivative e to the sine of x is going to be e to the cos of x, derivative of the outside function. Oops, I'm missing something here. Sorry about that. This should have an inside function here. I will correct it. But this should be derivative. I'll actually correct it right now. Here we are again. Sorry about that. Now we've got it right. If we are differentiating, we're using product rule. So we have to differentiate the u and leave the v the same, plus, and then leave the u and differentiate the v. So if we have a look here, to differentiate e to the sine of x, it's e to the sine of x coming back, the outside function, times derivative of the inside function, and the inside function is sine, so that's how we get cos. So this here, e to the sine x times cos x, is the derivative of e to the sine x. Multiplied by 2 ln x plus 1 as it is. Plus, then we have e to the sine of x as it is, multiplied by, and the derivative of 2 ln x plus 1, well, 2 ln x becomes 2 over x, and the plus 1 goes because it's constant, so e to the sine of x times 2 over x. And then that simplifies to quite a mouthful. This is quite a tough one, actually. Sorry about that. I've just simplified it, multiplied out a bit, but nothing will simplify there, so that's as far as it goes.